Welcome to one of our first lessons. This is Professor Kayden, and I'll be teaching you quadrilaterals. And if you guys want to learn rigid motions, you can hop on over to another video where Professor Devin will be teaching you rigid motions. Alright, without further ado, let's begin. Let's define what a quadrilateral is. A quadrilateral is a shape that has four sides. Four sides, okay? 1, 2, 3, 4. Let's get into our first type of quadrilateral, a parallelogram. A parallelogram is defined as a quadrilateral with two pairs of parallel sides. Now let's mark it up to help you guys visualize it. This side will be parallel to this side. This side will be parallel to this side. Let's go over these properties. The opposite sides are congruent, meaning that this side is congruent to this side. The opposite sides are parallel, which we have shown already. Now, let's get into this. Diagonals bisect each other. Now, diagonals is a line that connects two opposite vertices, which are these. The diagonals bisect each other, which means that this diagonal right here bisects this diagonal, cutting this one in two equal halves. Likewise, this one right here will cut this one into two equal halves. Additionally, a property of a parallelogram is that the consecutive angles are supplementary. Now, what are consecutive angles? First of all, let's name our vertices real quick. A, B, C, D. The consecutive angles are angles that share the same side. So angle A and angle B, right? They share the side AB. Likewise, angle D and angle C, they share the same side DB. Now, what does it mean to be supplementary? To be supplementary means that it adds up to 180 degrees. So for example, if angle A is 70, angle B must be 110. 110 plus 70 is equal to 180. Now, let me give you an example. So, pause the video real quick and figure out this question. Angle A is 35 degrees. Find angle B. If you said that angle B was 145 degrees, you're correct. A square is defined as a parallelogram with four congruent sides and four 90-degree angles. Let's draw it out to help you visualize it. Four congruent angles, sides, and four 90-degree angles here. These are all interior angles. Let's go over the diagonals. The diagonals are where we connect opposite vertices using a line. A square has two diagonals, and these diagonals are congruent to each other. They also perpendicularly bisect each other, meaning that at the place where they intersect, there will be 90-degree angles. Additionally, these two diagonals bisect each other, meaning that this diagonal here cuts this one into two equivalent parts. This diagonal will also do the same thing to this one right here. Finally, they bisect opposite angles. So, for example, we know that this is a 90-degree angle based on our definition right here. This will be cut into 45 and 45. Okay? Now, let's move on to our rectangle. A rectangle is defined as a parallelogram with four 90-degree angles. Just four 90-degree angles. One here, one here, one here, and one here. Now, they're diagonals. The diagonals will bisect each other. Like I said, this diagonal will bisect this diagonal, meaning that it will cut this one into two equal halves. They will also be congruent to each other. Finally, we move on to a rhombus. A rhombus is defined as a parallelogram with four congruent sides. 1, 2, 3, and 4. Their diagonals bisect each other. They also bisect opposite angles. Now, like the square, if this angle is 70 degrees, this means that this part will be 35 degrees. This part will also be 35 degrees. Finally, they also perpendicularly bisect each other at their point of intersection, which is right here. One 90-degree angle, two 90-degree angle, three 90-degree angle, and our last one. Do you guys notice anything similar? A square has four congruent sides, right? And four 90-degree angles. We see that a rectangle also has four 90-degree angles. A rhombus also has four congruent sides. This means that they are a combination of a rectangle and a rhombus. Now onto our last set of quadrilaterals. A trapezoid is a quadrilateral with at least one parallel side. Now these parallel sides are MN and LO. Like a parallelogram, consecutive angles are supplementary, meaning that angle N and angle O add up to 180. Likewise, angle M and angle L add up to 180 as well. And our last quadrilateral, an isosceles trapezoid, is a quadrilateral that has at least one parallel and equal legs. So these legs will be equal, and these legs will be equal. The base will be parallel and parallel. Now the properties. The diagonals of an isosceles trapezoid, they're both going to be congruent to one another. Since the legs are congruent to one another, we can also find that the base angles are congruent. To end this off, I'm going to give you 4 questions for you guys to answer. Now, look at the question 1 and read it. In the diagram below, a square cache diagonals AH and CS intersect at point Z. Now I'm going to give you guys a few seconds. Pause the video and solve the question. Alright, now you guys are back. Let's analyze the problem. AH and CS, they intersect at point Z right here. And we know that this is a square. And we're dealing with diagonals right here. Which statement is true? Measure ACZ. ACZ is greater than ZCH. Let's find ZCH. Now, what we've learned is that a square has 4 90-degree angles, and the diagonals bisect those opposite angles, meaning that this will be 45, and this will also be 45, meaning that this question is not correct. Now, let's look at 2. Measure of angle ACZ, ACZ is less than ASZ. ASZ is right here. Now, same thing. This 90-degree angle here is being cut into 2 by the diagonal CS. So this will be 45, this will be 45, this is 45. This is not correct, as these 2 angles are congruent to one another. Let's look at number 3. Measure AZC is equal to SHC. Now, SHC is 90 degrees, while we know that AZC, where's AZC? AZC would be 90 degrees. Now, the diagonals of a square, they perpendicularly bisect each other. So, it creates a 90-degree angle, meaning that answer choice 3 is correct. Now, let's move on to our next question. Parallelogram BEF with diagonals segment BT and segment HE is drawn below. Pause the video and answer the question. Alright, now that you're back, let's analyze the information. Parallelogram BEF and diagonals B and T. What additional information is sufficient to prove that BEF is a rectangle? BT is perpendicular to HE. BT is perpendicular to HE. Now we learned that the diagonals of a rectangle are only congruent to one another and bisect one another. Bisect one another. So let's base it off these two things, 1 and 2. Okay, BE is parallel to HT. BE is parallel to HT. Well, that doesn't really prove anything. Now, let's go to 3. BT is congruent to HE. BT, the diagonal BT, is congruent to HE. The correct answer is 3. On to our last set of questions. In quadrilateral TON, segment OW is congruent to segment TN, and segment OT is congruent to segment WN. Which additional information is sufficient to prove quadrilateral TON is a rhombus? Pause the video and try and solve the question, and come back to find the answer. Alright, welcome back. So, let's first draw out our quadrilateral to visualize it. Labels T, O, W, and N. Now, we are dealing with a quadrilateral TON, whether it is a rhombus or not, and we're finding sufficient evidence that proves that it is. So here I've written down the things that prove that it's a rhombus. A rhombus has 4 congruent sides. Their diagonals are perpendicular to each other. They also bisect each other. And they bisect opposite angles. Alright, now let's see. Look at answer choice 1. ON, alright, this is diagonal ON. It's perpendicular to TW. Now, look at our rules here, our rhombus rules. Does it fit any of it? Yes, it fits number 2, meaning that answer choice 1 is correct. Let's move on to number 10. Which congruent statement is sufficient to prove parallelogram mark is a rhombus? Pause the video and try and solve it. Welcome back. Now, let's draw out parallelogram mark. Sorry if this is not drawn to scale. M, A, R, and K. So, we want to solve that parallelogram mark is a rhombus. Now, look at the rhombus rules that I put down here. Okay, number 1, MA is congruent to MK. Now, look at this. If MA is congruent to MK, that means that KR is congruent to MK. The reason why is that it says that it's a parallelogram. A parallelogram's opposite sides are congruent, meaning that MA's opposite side, KR, is congruent to it. And MK's opposite side is congruent to AR, meaning that it completes the idea that a rhombus is a parallelogram that has 4 equal sides. This ends our quadrilateral video. Professor Kayden. I hope you guys learned something. I hope you guys followed it. But most importantly, make sure you guys hit that subscribe button and like the video.
Burning the bridge that